Okay, in this video, I just wanted to focus on how to answer these questions using Excel, since the videos that are attached to the actual homework questions show mostly how to do it with the z-tables and also how to do it with a graphing calculator. So it's easy to do these also with Excel as your technology instead of using a table or a calculator. For this one, it says we want the probability that z is less than 0.62. So we're looking for a left area. Remember, probability and area are the same in continuous probability distribution questions. So we know we're looking for left area, and that's because of the less than symbol here. So the value that's given here is actually a z-score that we want to see what's the probability of being less than that z-score. So the z boundary is 0.62. And we can use that to answer our question here by using NORM.something. Now, there's two options. You can use NORM.DIST or NORM.INV. These are the only two that you really want to look at. NORM.DIST, look what it says when I selected it. It says it returns the normal distribution for the specified mean and standard deviation. When I click on NORM.INV, it says it returns the inverse of the normal cumulative distribution. Now, that might not mean much to you, but let me just make a little note here for you to jot down. NORM.DIST means that you are going to be finding a probability. I need a bigger space here. Where should I put this note? I don't have enough room there. Let's put it down here. Use NORM.DIST to find an area, or in other words, a probability. Or you could say it the other way around, to find a probability or an area under the normal curve. Use NORM.INV to find a boundary from a known area. Okay, so when you're finding a probability, it's from a known boundary. So in this case, the known boundary was 0.62, and we were looking for probability, and I could tell because this reads P of reads probability of z being less than this boundary. All right, so whenever you see that type of notation with the P there, and it's a normal distribution, you know you're going to be using NORM.DIST. Now, if it also says standard, that means that your mean is 0 and your standard deviation is 1. So standard normal just means that the mean equals 0 and the standard deviation equals 1. Okay, so now that I know I'm supposed to use NORM.DIST to find this area, I'm going to put in my z boundary of 0.62, then my mean of 0, because it says it's a z-score, and if it's a z-score or if it says standard, either one, if you see a z or if you see the word standard, that means your mean is 0 and your standard deviation is 1. And we're always going to choose true for cumulative. So there will never be a time that you should ever choose false. Great, and then we have our answer for that. Now it's important to note that I said left area. I made a point to note that this was a left area because that's what NORM.DIST and NORM.INV understand. They understand left-hand setups. So whatever your question is, if it's not already, this one happened to already be left-handed, but some of them are not, like this one. This one is for a greater than, right? So now how do we change the way we approach this problem? seeing that we now want to find a right area. Well, we can first find the left area, and then the right area can be found by doing 1 minus the left area, because the entire area under the bell curve has to add up to 1. So if you know one side of it, you know the other side implicitly. You can just use the law of complementary events and subtract from 1. So I will find the left area, and then I will subtract it from 1 to get my final answer. So the z-bound, again, is given here as 1.59. So I'm going to put in 1.59 and just use my norm.dist again with the left boundary of the z-score of 1.59. Now you can either click on the cell containing it or type it in by hand. And you can also set this up so that you have like an automatic calculator if you want to be real fancy and try to be more efficient. You can also type in 1 for cumulative instead of typing the word true. All right, so I'll do that again. I did it that time by typing in the answer, or in the boundary 1.59, just typed it in. But if you wanted to make a calculator out of this, you could click on the cell containing the boundary, and you could also get even more fancy. You can do things like, I'll just take a moment to show you how I set mine up. I'll do the mean, the standard deviation, then I'll do the boundary, and then I'll do left area, right area. And you can even do between area if you want to get really fancy. So the mean here, since it was standard, is 0. Standard deviation is 1. The boundary was given as 1.59. So my left area is this x boundary or z boundary because it's standard. The mean is 0 and the standard deviation is 1. I forgot to say cumulative, so let me fix that. Back in here and put true for cumulative, or you can just type a 1 to say yes. All right, now the right area is 1 minus the left area. So being that my answer was supposed to be a right area, I'm going to put that one in here. Okay. Now, if I get a different question, so let's say I do a new version of this, and now it wants z greater than negative 0.49, it's still a z-score, so the mean is still 0 and the standard deviation is still 1. But the boundary has changed to negative 0.49. And so just by retyping that, I have my new correct answer here. So it's kind of convenient. It's just cool to, you know, every time I do a new version, as long as it's a right area with a z-score, I just need to change my boundary, my z-score boundary. And notice I didn't say z-bound here because it could also be an x-bound. And when you put in the mean and the standard deviation, that will sort it out for you. So we're just going to say, for this one, it was 2.6. So notice I'm just changing my boundary. Then I get my new correct answer. Oh, didn't like that one. Did I miss something? 2.6. It might just be that I need to round it. Let's try rounding it to 0.9953. I didn't like that either. What's the answer supposed to be? Oh, you may have noticed I was copying the left area answer instead of the right area answer. Now, before we go on, I'd like to use this as an opportunity to talk about why, even though I haven't shown it in this video, I do recommend that you always draw a picture, because if you understand that your mean is in the center at 0 for standard deviations or for standard normal distributions, and then you have this boundary of positive 2.6, that would be over here on the right. And so with a right area, it says greater than 2.6, this should be a very small probability. right? And it's definitely less than half, because from the center over, you have half. I'm trying to get my highlighter here. This is all together 0.5. So anything smaller than that has got to be less than 0.5. So I really should have noticed that my answer didn't make any sense. And drawing a sketch does help with that a lot. Let me show you another one. So again, I have, I'm going to try to erase this real quick and draw a sketch too. This is really how I recommend writing these problems, is start with your sketch, little messy sketch. It's a standard, so I have my z-score boundaries with a mean of 0, and then my boundary is 1.62, and it's to the right, so I know this is going to be a probability that is less than 0.5. Right now, when I put in my boundary of 1.62, I see that my right area is less than, it's a small right area, and it's definitely less than half. So that would make sense as my answer. Okay. And if it's a, let me get another one where it's another negative. Oh, here we go. There's a good one. So I'm going to now do the same thing again, just my sketch really quickly. And this time my z-score is over here on the left, negative 0.22. So my right area is actually greater than 0.5. This is a larger area, and it's definitely going to be greater than 0.5, greater than half. So I like to have you guys think about that before you even find your answer, just to make sure that when you're entering your answer, it makes sense to you. See how that's more than 0.5? So it's more than half of the total area under the curve. So that makes sense. Okay, now, what if you have one like this where you have to get in between two values? So I told you about between area. Well, for that, you have to get more fancy. And what I would recommend is that you actually set it up a little differently. You could set it up so that you have a left bound and a right bound, and then a left tail and a right. Or you could say, how about this? Let's do a larger left area and a smaller left area. Let's do it like that. All right, and then you'll get the probability of the between area. All right, so how it goes like this. Again, we have a z-score, so we have mean of 0 and standard deviation of 1, so I'm going to leave those like they are. Then the left boundary is negative 1.59, so I'm going to put that in, negative 1.59. The right boundary is 0.51, so put that in for the right bound, 0.51. The smaller left area, or sorry, larger left area. So again, it's going to help a lot if we have a sketch to help us understand what we're talking about here. So I'm going to go ahead and sketch this out. So I have my curve, 0 in the center. Then I'm just going to use a different color for some reason. I like it. We have this color. We have this one, negative 1.59 here. And then we have another color we'll use for our other area of 0.51. Okay, so I meant to say my other boundary, not my other area. These are boundaries down here. These are z-scores down here. All right, so now the larger left area is going to be from the farther, the rightmost bound. So that's going to give me the larger left area. So I'm going to use NORM.DIST on my right boundary with, again, the mean of 0 and the standard deviation of 1. And of course, true for cumulative, or just type 1. And then for my smaller left area, I'm going to do from here over. All right, so now I do the exact same thing again, NORM.DIST, and I'm going to put in my left boundary, then the mean of 0, the standard deviation of 1, and true for cumulative. And now that gives me that. So the orange region has an area of 0.69497. The smaller area in the pink has this area, or purple, whatever you want to call that color. And the area in between is what I'm actually looking for as my final answer. So this yellow region here. So in order to find that, I can take the larger orange part and take off the little purple part. So that's what I'm going to do. I'm going to subtract the larger left area minus the smaller left area and get what's left over after that. It's the in-between area. Okay, and that's how you use the normal distribution in Excel. Now, the only thing that we haven't talked about is for questions where it's not standard, like this one. It says a manufacturer knows that their items have a normally distributed lifespan with a mean of 15 years and a standard deviation of 3.9 years. Okay, so now let's get rid of everything here on our little calculator. And we're going to be changing to the mean of 15. This is not standard because the mean is not 0, but it is still normal. Okay, but we have a different mean and a different standard deviation given in this problem. Then it says if you randomly purchase one item, what is the probability it will last longer than 20 years? Okay, so then to write that in probability notation, the probability that X will last longer, so greater than a 20-year lifespan. Okay, so now what you have is a normal curve with 15 in the middle, and you have a boundary of 20 over to the right here, and you're looking for a right shaded region to represent the probability of it lasting longer than 20 years. Now, with Excel, it's very easy to simply use that as your either boundary. I mean, you can set this up like we did before with the right area, left area, and then the right area. Since we want the right area, we use the NORM.DIST with 20 and then a mean of 15, the standard deviation of 3.9, and true for cumulative. And you could use that as your left bound or your right bound if you wanted to set it up in your calculator. If you wanted to say like your left bound or a single boundary, if it's one that doesn't have a between single. All right, so you could have put it here if you wanted to just have it give you the larger or the smaller left area. So the smaller left area, what would it be? It would be the larger left area. I'm confusing the situation. Let's keep it simple. Let's go back to, maybe you could have two separate calculators because I think this might throw you off more than anything. So if you do want to have a calculator, just have a separate one for when you have a single boundary, and then you'll have for your left area answer and your right area. Okay, so now your boundary here is 20 and your left area would be from 20, then a mean of 15 and a standard deviation of 3.9 and true for cumulative. And then your right area would be 1 minus the left area. So this answer right here is the left side, and that makes sense because you can see it's very large. It's close to 1, so it would make sense that this is 0.9. And then the smaller region on the other side is actually the answer that we wanted to give, since it said greater than. And so it does make sense that the answer should be close to it's almost 0.1, 10% almost. So 0.099, what do you want to say? Now it says to 3 decimal places. So when you round this to 3 decimal places, it does round off to 0.1. Okay, now that is what you do if you're looking for an area. Now, if you were looking for a boundary, that is when you use NORM.INV. So all these that say probability, they're all going to be using NORM.DIST. But when you get to one where you have to, so still all of these say probability, probability, probability. Oh, I'm doing, gotta love me. I'm doing the new version of the same problem over and over again. That doesn't help. Okay, let's find one where we actually have to find C. Okay, so this is a good example. So for a standard normal distribution, find the C that goes right here. So they've given us, instead this time, they've given us the actual probability, and you're looking for the z-score boundary that would have that probability. So what you do is, again, I recommend a picture. Start with your curve. It says it's a z-score, so our mean is 0. And it's a given boundary, but we don't know what it is, right? So C is unknown. It's going to go somewhere maybe here or perhaps over here. What we need to do is figure out what that value is, but that's going to be our boundary. Now, one way you can tell or narrow it down is if the given probability is greater than half, that will tell you which side to put it on, combined with whether this is a left area or a right area. So this is a left area. You can see the less than symbol there. So being that I have a left shaded region that has to have an area of 0.6141, that means that the boundary has to be farther from the left. It has to be all the way past the mean of 0. Because if we're right here, just this area would be 0.5, because that's half of the total area, which has to be 1. So knowing that it's greater than that means it's going to be a positive z-score that we're looking for. So C is a positive z-score. C is, okay. Now, you're going to use NORM.INV to find this, because you know the probability, but you need to, I have a little baby knocking at my door, so I'm just trying to finish this up real quick. You need to put in it says your probability first, and it has to be a left probability. So if this were to say greater than, I would have to subtract this from 1 first before I could feed it to the NORM.INV. But being that this is a left probability, I can go ahead and put it in directly as 0.6141 with a mean of 0 and a standard deviation of 1, again, because it says it's standard normal and it's a z-score boundary. So there's my answer for that. So C would have to be positive 0.29 approximately. And I accidentally put in a little negative symbol there. There we go. Okay. Now, if you're given a percentile one, that's the same type of problem, except for it's given to you in slightly different terminology. So all you need to do is just realize that the percentile is giving you a percentage on the lower side. So to say P26, that means the 26th percentile. So the percentile is a divider. for the lower 26%, and percentages as decimals are probabilities, really. So that means that I have a boundary that is cutting off bottom 0.26 area, 0.26 area, and I need to know what boundary that is. And so we have to, again, go through finding the mean, the standard deviation, the left boundary, the boundary, and then the left area is going to be used to find the boundary in this case. So we could say it in a different order. Put in the left area and then find the boundary. Okay, so the mean, it says here that there is a mean of 0 and a standard deviation of 1. So this is standard normal. So we will be using z-scores again. You could do this one with a z-score table if you wanted to. The left area is 0.26. And then we use NORM.INVERSE with the 0.26 probability, the mean of 0, and the standard deviation of 1. And that gives you the boundary that you needed for degrees in degrees Celsius. It says to round to 3 decimal places. So we'll round that to 0.643. And there you go. So that was just a quick and dirty lesson, and I hope that was helpful to you to supplement the videos that are already attached to the questions. And also don't forget about the playlist of videos that I have for each lesson. When you go in to your lesson folders, there will be one called videos, and you can find links to other videos that might be helpful. For instance, the normal distribution lesson 8, when you go to videos folder, there is a link to the playlist of YouTube videos that you may find useful, in addition to both the class participation videos and the videos attached to the GLA assignments. So as always, please keep in touch. Let me know how I can help. See me during office hours. And I hope you're all enjoying learning this section.